Everybody, welcome back. This is another lab walkthrough video, and this time we're going to be talking about the density hands-on lab. So our objectives of this lab are to calculate volume using water displacement, use the density equation to solve for either mass, volume, or density itself, and to calculate percent error using table S. Part 1 talks about using water displacement, so you'll record the mass, the volume of your graduated cylinder, and calculate your density. Part 2, you're going to be measuring cubes of wood, calculating length, width, and height, and the mass, and then doing calculations. Part 3, you're going to be doing the same with copper and aluminum. And then calculating the percent error for those things.
Okay, so at your station, you're going to have this blue bin with a ruler, a 50 milliliter graduated cylinder, a second smaller bin with 2 wood blocks, one labeled H, one labeled E, 2 metal cubes. This one is copper, it has the Cu to denote that. And the silver one is aluminum, and there's the Al for that one. You'll have a rubber stopper, and you'll have your scale. You just pop this open and turn it on. Now, part 1 is finding the weird object with water displacement. So there's no exact formula for volume for this rubber stopper. So what we're going to do is take the mass of it. So sometimes when you turn on the scale, it might have a number, which it shouldn't start 0. It should start 0 rather. First thing you want to do is double check the unit. It should say G for grams. If we zoom in there, G for grams. But right now you see it says negative 2.08 and there's nothing on it. So we're going to hit the tare button, which zeroes it. Once you place our rubber stopper on it, and so we get 4.10 grams, we're going to write that down. Turn it off, just close it, put it off to the side. Then we're going to take our graduated cylinder and fill it up about halfway. It doesn't need to be exact. So filled it up. Now when you're looking at a graduated cylinder, you want to look at where the meniscus is. So that's that middle part. So again, you have 2 different sides. You have 40 up to 0. You have 10. We're going to start here and go up. This is 30, about 30, where are we? 5, 6, about 37 milliliters in here. So we're going to record that as our initial. Again, you may have a different initial, that is totally okay. Because it matters how much the water changes, not what the initial or final volume specifically is. So we're going to take our dropper and throw it in there. And so now our water level rose to about 41 milliliters. And so we're going to use that as our final volume. So then once that's done, we can do final minus initial to get the volume of our stopper. So then you have your mass, your volume, and you're able to calculate density. Now, to clean this part up, just dump the water in the sink, and you can throw the graduated cylinder back in, and we'll keep the stopper off to the side. There will be a paper towel up at the teacher's desk in case you want to use that. Now, part 2 is looking at the 2 different pieces of wood. So we have H and we have E. Now for each of them, we're going to take the mass again. So right now it is 0'd. So the mass of E is 11.79 grams. So we're going to record that in the cube E section. The mass for cube H is 6.48 grams. We're going to record that in the cube H. Then we're going to measure the length. So these are cubes. Length times width times height is the volume, and all of the sides are the same. So if you look at it, again, we want to look at our ruler carefully, not at the end, but where that starts is where we're going to put this. So this is 2.5, oops, move it over a little bit, 2.5 centimeters. So it means each side is 2.5 centimeters. We'll record that. And to calculate the volume, it would be 2.5 times 2.5 times 2.5. So then that gives you enough information to calculate the density for the wood blocks. And then given the information in the directions over here, you'll be able to figure out if which block is oak and which block is pine. Now, last section is very, very similar. We're going to then calculate the density of the two metal blocks. So I'm telling you this is copper, I'm telling you this is aluminum. So again, we're going to take the mass of both of these. So copper has a mass of 146.36 grams. We're going to record that. Aluminum has a mass of 44.73 grams. Again, we're going to record that. And all the cubes are the same size, but just to show you, this is going to be 2.5 centimeters as well for the length, the width, and the height. So using all that information, you're going to then calculate the density, and then that's going to represent your measured value.